Let's explore how the simplest C program looks like in x86 assembly. That's going to be the Hello World program. I'm going to use a tool that is called Rizin, and this is an open source reverse engineering program. If you go here to the official website, rizin.re, and then click here on install, you can see that you can easily get it with the package manager if you have one of these distros on Linux, or on Windows you can use the winget package manager, or Mac OS you can use brew. Now in my case I'm running Debian, so I just built it from source. So just click here on source. You're going to want to clone this repository and then open up the README. And building it is very simple. You just run these 3 commands. And you're going to want to install Mesin, which is the build system that they use. Okay, so I'm going to start by writing a simple C program that is going to say hello world. And then we're going to open up with Rizin. So I'm going to call it main.c. I'm just going to use printf. Now I'm going to save this. I'm going to build this with GCC. Output is going to be called main. Now if we run this, make sure that works fine. And now I can open this up with Rizin. So I'm going to run Rizin and then main. Okay, now I can see that Rizin is command driven. So we're opened up on the Rizin CLI. And this is the current address that we're on right now. So I can just inspect this in a couple of ways. Since I know that Rizin opens up on the entry point, I'm just going to use the pd command. So I'm going to run pd and then question mark to get help about pd. And pd is print disassembly, as you can see over here. And you can tell pd I want to print a specific number of instructions. For example, print 3 instructions. So I'm going to clear the screen with Control L and type in pd and then 5. And I can see 5 instructions from the current offset we're on right now. And you can see also that we're on the entry point of the program. Now if I just print a couple more instructions, for example 20, you can see that we're not actually in the code of our main function, but this is actually general initialization code. Because you can see, for example, that it's calling something from the libc start main. Now to get to our function, I'm going to use the seek command. So I'm going to run s and then question mark. And you can see that the simple case is just seeking to a specific address. So I'm going to run s and then seek to the main address. And now I can see that the address here has changed. And if I run here pd again, let's run, for example, pd10, print 10 instructions. Now you can see it looks much more familiar. Here's the hello world string. And notice that it calls puts. It doesn't call printf as we called in our code. This is actually an optimization that the compiler does, because it noticed that we're just using a single simple string. And if you take a look at the man page for puts, you can see it just gets a simple string. So no need for the extra complexity of printf that also accepts additional arguments and flags. You can just simplify it. After calling puts, you can see that it's returning. And over here on this line, it's actually setting the exit code. So the exit code is set to 0. This means the program was successful. And by the way, notice that Rizin has added here the address that the string comes from and the string itself. This is just to help us. Also notice that in the assembly code here, it's transferred to the REX register. And then REX is transferred to the RDI register before calling puts. And RDI is actually, by calling convention, the first argument on Linux systems, specifically in the case of course, x64 assembly. Now, we can, of course, inspect the string itself, but if we just seek to this address, so I'm going to seek to this address, and now I'm going to use the px command. So let's take a look at the help. And this is show hex dump. And we can, of course, use px with a specific length. So, for example, I want to print a little bit of the hex. So I'm going to use px and then print, for example, 10 numbers. Now you can see we can see part of the string. Print a little more. And we can see the full string and null terminator after the string. Okay, I'm going to seek back to the main function. and take a look here at the disassembly again. Okay, what I want to do now is I want to modify the exit code of the program. You can see that if I run the program, and I take a look at the exit code, so that's going to be $? Here on bash. It's currently 0. Let's make it return something else without modifying the C code, but actually modifying the machine code itself. Start by seeking to the instruction you want to change. In my case, it's going to be this instruction. So seek to this address. So I'm going to copy this and seek to it. And now if I take a look with print to disassembly, and this time let's print just 2, you can see I'm on the instruction I want to change. So what I'm going to do is I'm going to use the WA command, write assembly. And you can just pass in the instructions you want to put instead of the current one. So that's going to be WA. And I'm just going to copy this. Instead of zeros, just going to be 7. Oh, and of course you're going to want to open the file in write mode, because currently we're only on read only. And you can use the OO command, specifically this one, OO plus, reopen current file in write mode. And now if we just run the same command again, write assembly, and replace it with this instruction. And now let's take a look at the disassembly. And you can see now the new instruction here. By the way, this is fine because this instruction has the same size as the previous instruction, because it's just a small change of the number. Of course, in the x86 world, instructions have variable sizes, so you want to make sure you don't mess with the instruction following it. Okay, and now if we go back here and run the program again. Oh, and I'm going to need to exit rizin, run the program again. Now let's take a look at the exit code. And you can see we successfully changed it.